All right, so Kennedy, we need to prove that segment AB is congruent to segment CD. We already see that they have a side and an angle already in common that's corresponding. So what I can clearly see is that we need side, angle, side in order to prove that these two triangles are congruent. And if I could show that these two triangles are congruent, I'll be able to prove that corresponding parts are congruent. So what we see here is all of our given statements I have here already. What I see here that's going to help me out is this right here. I see that AF is congruent to CE. So this part, so AF is congruent to CE. Let's take a look at that. If AF is congruent to CE, I also see that segment AE plus segment EF is equal to CE. Well, CE is equal to segment CF plus FE or EF. But again, this is AF is congruent to CF plus EF or FE is CE. We were already given that. That's here. But let's focus on it written this way, because what you have to see is that EF, let's write this down, EF is congruent to EF, and that's the reflexive property. They're already equal to each other. So we clearly just proved that what we already knew, no, not what we already knew. Here's the AE, which is this, and here's the CF, which is this. We just proved that those two parts are equal. So I can now say that AE is congruent to CF, and that's by way of using the segment addition postulate. And now that we have those equal to one another, I can now say that triangle BAE, triangle BAE, is congruent to triangle CFD by way of side, angle, side. Side, angle, side. Now that these two triangles are congruent, we can now say what we have enough to say what we wanted in the first place. That segment AB is congruent to segment CD because corresponding parts of congruent triangles are congruent. So that's that one. Pause the video, take a screenshot of this so that you have it. Let's take a look at our final example. Again, we always have in our two-column proofs statements and reasons. I'm going to make sure that all of my given are written first and that everything is marked. So segment QD is congruent to segment UA. That's QD, that's UA. They are congruent. I can cross them out. Triangle QDA is congruent. I'm sorry. Angle QDA is congruent to angle UAD. That's these right here. Okay. So we need to prove that these two triangles, I'll shade this one in blue. So triangle QDA, that's this one, is congruent to triangle UAD. That's this one. And what we see is what's double shaded is a part of both triangles. So we have a side and we have an angle. What we need is this part. Well, it's pretty easy. We did all that work in the last example during our session when we worked on this problem, but I can clearly see that segment DA is congruent to segment DA. So what we have here is we have enough to say that these two triangles are congruent right away because we have side, angle, side, side, angle, side. So triangle QDA is congruent to triangle UAD by way of side, angle, side. There is your answer. We did a lot more work the last time, but when I looked at it this time, I saw that it was a lot simpler. We already had a side, we already had an angle, and that second side that we needed is actually reflexive because it's a part of both triangles. I really hope this helps. I also would hope that you would use different color or different methods of shading to make what we need stand out differently, if that makes sense. So, really hope this helps.